Hi friends, welcome back. Today we're talking about the change of base formula, and I brought this up in another lesson, but let's dive a little deeper into that. Our base, remember in invisible math, you see something that looks like this, log 15 like that. Part of our invisible math is if our base is not shown, it's assumed to be a 10, right? So we don't write the 10 in there. You can if you want, but it's not necessary. The only time we write a number in there is if it's something that is not 10. So for example, if we have log base 16 of 64, in order for us to do this using the change of base formula, we would say, okay, log 64, because we take this part of our value that we're evaluating over log, and we use our base here, 16. Now, 64 divided by 16 will give you 4, right? But you can't just cancel these out and say log base 4. It doesn't work like that. So what we have to do is say, okay, log base, so you go and enter it into your calculator, log base 64 divided by log base 16. And that would give you 1.5. So this would be 1.5. Now let's think about the things that we have learned on evaluating logs without a calculator. Let's do a little side work here. Log base 64, and without a calculator, so we'll slap an x on the end, and we'll use our snail. 16 to the x power equals 64. 16 to the x power equals 64. So 16, I can take that down to a friendly number and say that that is 4 squared to the x power. I also know that if we do 4 to the third power, we would end up with 64 as well. That's why it's a good idea. I was just looking at the cheat sheet that we had in a previous video. Write all your perfect squares down, write all your perfect cubes and perfect 4s. That will help. So we know that 4 to the third power is 64. Now you see that I have the same bases. So what I have here is 2x equals 3. Divide both sides by 2, and I get x equals 3 over 2, which we also know is 1.5. So we end up with the same answer either way, but I wanted you to see how to use that change of base formula. It's not always friendly. Like looking at number 2 here, this is not going to be a friendly one. So we have log base, or log 54 over log 2. And if we go to enter that in our calculator, we end up with log 54 divided by, oops, sorry about that, log 2 gives us 5.7548. We want to round to 4 decimal places, so instead of 488, I'm going to say 49. So that gives us 5.7549. And you can use a little approximately just to say, hey, I'm rounding in this case. Okay, let's look at our last one that we have here, log base 5 to the 1 over 25. Again, we could probably solve, I see that this is a friendly number, it's 5 squared here, but we want to use our change of base formula. So log 1 over 25 divided by log over 5. Again, let's enter that into our calculator. 1 over 25, we enter it as a fraction, but you got to be really careful to make sure that you're using your parentheses. So 1 divided by 25 equals all that garbage. Whatever that is, I'm going to divide it by log 5. And when I do that, I end up with -2. Throwing pens across here equals -2. So hopefully now you understand your change of base formula and that this helps by seeing it evaluated a few times. Good luck, and we'll see you next time.